Section 10.5, Reflection and Refraction. So when a wave bounces off of a surface, we say that it's reflected. When a sound wave bounces off a surface, we say the same thing. We say that it's a reflection. For sound, we call reflections echoes. If you have multiple sound waves that bounce off of multiple locations and all combine together, you get what are known as reverberations. You hear this often if you go into a cement parking deck and you clap your hands or something like that. You'll hear multiple echoes echoing off of the walls of the parking garage. You also hear this in bathrooms sometimes. That's why your voice sounds strange. In terms of reflection of waves, we describe that using the law of reflection, which just says that the angle of incidence of a wave is equal to the angle of reflection of a wave. That is, if the angle is measured from a line perpendicular to the surface. For a flat, smooth surface, when a ray comes in and hits whatever the surface is, it'll bounce off at the same angle at which it hits the surface. If the surface is not smooth, we get what's known as diffuse reflection. So when sound or light strikes a diffuse surface, just means a non-smooth surface, a really bumpy surface, the law of reflection still holds. But because the surface isn't smooth, the reflected rays bounce off in all sorts of different directions. So this occurs naturally, and this is why you can see objects. Light does this. But this also occurs naturally with sound. That's why your voice will sound different in different rooms, depending on where you are and how you observe your voice. One way this is readily apparent is when you're driving at night just after it's rained. So puddles of water on the road have very smooth surfaces, so they reflect light in very smooth ways. You can see reflections of streetlights and things in these smooth surfaces, and because of that, it is harder to see the road at that particular time. In general, when there's no water on the road, then the surface is not very smooth at all, so all of the light rays reflect off in all different directions, and the ground's illuminated. Refraction occurs whenever a wave meets the boundary between two different mediums. And it occurs because the wave will generally travel at different speeds in those media. Again, this occurs with sound and light waves, which we'll talk more about in the next chapter. For example, wavefronts can approach a boundary and travel at some particular speed in air. So each of these would represent essentially the maximum point, let's say, on a wave. And these wavefronts will reach this boundary. Now, it'll speed up when it reaches the water because sound travels faster in water than it does in air. And so because these waves start to speed up, they get closer and closer together, and it causes the sound to bend, the sound wave to bend. If you were underneath the water listening to someone speaking above it, you would observe their sound to be coming from a different place than where they were standing. And this happens if people try to talk to you when they're standing outside of a pool and you're underneath the pool. This can also happen in just regular air if some air near the surface is warmer and up above is cooler, or vice versa. Sound waves can bend depending on different temperatures in the air. This is because the sound waves travel at different speeds. So some at the top in the cooler air where they travel slower will bend, and in the warmer air where they travel faster, they spread out.